So a way of saying what Solstice just showed us was she showed what doing this does to the graph of f of x, and what doing this does to the graph of the function. So shifts everybody up by 1, shifts up by 1, and then this one shifts down by 1, right? So what we have also is that when we do this, it will shift right by 1. And when we do this, when the plus and minus 1 is inside the parenthesis, it will shift left. When we multiply, it will stretch, make it longer. And when we divide, it will stretch in a different way. It will make it wider. Like this, yeah. So the best way to do this is get a function and then check it, yeah. Check these using maybe f of x equal to x squared and see how it will look different. So you have to, but first you have to know that x squared kind of looks like this, right? So this is x squared. And then x squared plus 1 is going to shift everybody up by 1. Yeah. X squared minus 1 is going to shift everybody down by 1. So it's going to be like this. And then these are more complicated. This one is x minus 1 squared. And you know that when x equals to 1, x minus 1 squared is 0, right? So the vertex of the what we call parabola is going to be here. So it's going to look like, I don't draw very well, obviously. I distorted my function, but if I hadn't distorted it, so shifts right by 1, and then the other one, the plus 1, is going to shift left by 1. So my suggestion is use a function whose graph you know and just play around with it and check how the graphs get shifted. Yeah. And start with a function that's easy. So start with either x squared or absolute value of x, or just plain x. This is part of the final project anyway. The final project is not going to ask for functions that are much harder than these. So if you start drawing these and checking their different transformations, it's going to help you do the final project as well. Yeah, is that okay?
Professor Yan, can you walk through just doing a few different values for x on either x squared or absolute value of x or just x?
So let's say this one, right? F of x equals just x, right? So what would be f of negative x? What would that be, right? If I plug in
question or comment.
Yeah, sorry.
I was trying to visualize that means it moves this way, right?
When I multiply by minus 1, it's a lot different. When I multiply by minus 1, it's going to reflect. This is why, look. So we all know f of x equal x, how it looks like, right? It's going to be that line here. This one. Oh. I can't. Make it go through the 0, 0. Okay, this one. This is f of x equals x, yes? It goes through the points 0. When x equals to 0, f of x equals to 0. When x equals to 1, x equals to 1. When x equals to negative 1, is equal to negative 1, right? So if this is how it's going to look. So if I want to draw this one, how would I do this one? F of x, f of negative x, it's going to be negative x. So whenever my x, when my x is 0, the y value is still going to be 0. When my x is 1, the value is going to be -1. When my x is -1, it's going to be 1, right? Because it's going to change the sign here. So the graph is actually going to look like this.
Does it need to be f of -x, or could that also be f of x equals -x?
No, I'm just saying this is still, the basic function is f of x equals x.
Ah, okay.
So what happens when I make this transformation, this change, right? What happens if I change the sign inside? Then it becomes -x. So then here it will, when it's 1, it's going to be -1. So it's going to be here. And when it's -1, the y value is going to be 1. So it's going to be here. So this is going to be. But when you compare these two graphs, one is a reflection of the other one. Right? You reflected it like this. However, you can see this because I chose f of x equals x. If I had chosen a different function, it would be different. Like if it had been absolute value, for example, I won't be able to tell the difference. We'll see why. Like if f of x was equal to absolute value of x, the graph looks like this. Yeah. 1, 1, and 1, and then -1 also gives me 1, right? But if I, in this case, what happens to -x? Absolute value of -x is still the same as x. So I'll reflect it, but because it's already symmetric, I won't be able to tell the difference. So the f of -x is still going to look like this. Right. However, that thing that Solstice did will make a difference. So let's see here. What happens if I do f of x plus 1? So that's going to be absolute value of x plus 1. So this graph is going to look like this. It's still a V, but now the vertex of the V starts at 1. When x equals to 0, I have absolute value of 0 plus 1. So this is where I get, right? So basically, I move the V up by 1 unit. Everybody gets moved up by 1 unit. This is where it gets tricky. The tricky part is when we want to add the 1 inside the parentheses of the f. So for this case, I think it's a good idea to plug in some values. When x equals to 0, I have absolute value of 0 plus 1, I have 1. When x equals to 1, I have 2. When x equals to -1, I have 0. When x equals to -3, I have -3 plus 1, -2. Absolute value is going to give me 2, right? So when I draw this one, the graph is going to look like this. It goes through 0, 1. It goes to 1 and 2. It goes through -1 and 0. And it goes through -3 and 2. So it's going to look like this. It got shifted to the left by 1. Why is that? Because originally, the y was 0 when what was inside the parentheses was 0, right? But for now, to make this guy 0, I need my x to be -1. So my v shifted from x equal to 0 to x equal to -1. But this is a little tricky. That move inside the parentheses, I encourage you to check with more functions and then draw them carefully. And then you will see that it's actually a horizontal shift. Yeah, so basically what we have in the end is like this. We can say f of x plus 1 equals shifts up by 1. F of x minus 1 equals shifts down by 1. F of x plus 1 equals shifts left by 1. F of x minus 1 equals shifts right by 1. F of negative x equals reflection with respect to the vertical line. Negative f of x, if the negative is outside, is equal to reflection with respect to the horizontal line. After you understand these, then I suggest you check out what happens to 2 times f of x and stuff like that. Those are going to be stretches or compressions. Yeah, and try first with like easy functions. Don't draw something really strange. So you can just start with the x squared, x cubed, so that you can actually plug in the values and check. Okay, so that's actually also objective 6, which is graph absolute value functions. Yeah, absolute value functions is like 2 straight lines that make a V shape going through the 0, 0. Right. The reason why this is the case is because this is how we define the absolute value function. Absolute value will return the original value if it's 0 or positive, and will flip the sign if it's negative. So absolute value always gives you a 0 or positive value, right? So I don't know if this is this is the official definition of absolute value. Absolute value of x equals to x when it's no, I made it wrong. Dang. Wait. It's greater or equal, and it's equal to negative x when x is negative. All right. So basically, it's saying that when my x is positive is equal to x, and then when my x is negative is going to be negative x.